Action. Good. Right. Shh. Elliot. Use integration to find the exact area of the region enclosed by y equals x squared plus 4x, the x-axis, and the lines x equals 3 and x equals 5. We don't need to know what this looks like. They haven't given us a diagram of it. If we really felt we wanted to, we could do a sketch of it, but it's not a big deal. Part A, it's going to be, the graph is doing something like that. There are the values 3 and 5. And so what it's saying is that the area is, as we've just said, the integral between 3 and 5 of x squared is 4x dx. That's all that it wants us to do. And now we need to evaluate this. So if we integrate x squared plus 4x, what do we get?
X cubed over 3 plus 2x squared.
Why is it 2x squared? 4x squared over 2, and the 4 and the 2 will cancel out. Very good. Alright, and then we put the numbers in, so we sub in the top value and sub in the bottom value and subtract. So we've got 5 cubed over 3 plus 2 times 5 squared. Take away 3 cubed over 3 plus 2 times 3 squared. We're in core 2. I keep reminding you of this, so you've got a calculator, so you can type this straight into your calculator if you're careful. We've got 125 over 3 plus 50 there. We're taking away, what would that be, 9 plus 18.
Why do you take each one away from the other? Like, why are you taking away that bracket?
You put the top limit in,
Yeah.
and that gives you this value,
Yeah.
and then you subtract the value when you put the bottom limit in. Because what it's doing is it's giving you the area all the way from the upper value down to the y-axis.
Oh, right,
so you
yeah.
need to take away that bit from it to leave you with the shaded bit.
Yeah.
Okay. So we're getting some kind of answer. 125 over 3 plus another 3, which is going to be
194 over 3.
There we go. The question said, I believe, said the exact area, didn't it? So we're making absolutely certain at the end here that we give an exact area. If you want to write whatever that is as a mixed number, what, 64 and 2/3. If you want to write 64 and 2/3, that's fine.
Wow.
But 194 over 3 is fine. Okay. Remember, this is, have I said this yet? This question was parts A, B and C, so we've got 3 bits on the same topic but not directly connected. So part B, Will, what you can say? Yeah. Find that the integral of 2 minus 6 root 1. Okay, somebody do that for me then. Integrate 2 with respect to y, and we get 2y.
Minus 6y. Minus 6.
We maybe should have done another step here, shouldn't we? We should have thought about this as being the integral is 2 minus 6y to the half. That's right.
Yeah, so it's minus 6y power 3 over 2. Over 3 over 2.
Over 3 over 2, very good.
And then
Let's see.
Y over 3 over 2.
Because we're adding 1 to the power, it's 6y to the half. So we add 1 to the half to get 3 over 2, and divide by the new power, so divided by 3 over 2.
Could you just...
But, you're about to tell me this is 2y, and then this, if we divide by 3 over 2,
flip it over and times it and then simplify. You get 2y minus 4y to the power 3 over 2.
okay.
Could you just leave it like that? Top one.
It's better, I think we should simplify it. So rather than leaving it over 3 over 2, the fraction you're dividing by and multiplying, so 6 times 2/3 is 4. So you get that. And now this is going to take us a little while. Shh. Part C is what we call an improper integral. And that's what it looks like. It's 8 over x cubed between 1 and infinity. Right. Now this is a big deal. We can't work with infinity. You haven't got an infinity button on your calculator. You can't sub that into equations because you don't have a numerical value for it. So the way that I'd encourage you to deal with this kind of question is to, instead of working out that integral, let's make up our own sum. Let's do the integral from 1 to k of 8x to the minus 3 dx. And let's work with that. So that avoids all this problem with infinity. We're going to use k instead. So we integrate it. If you integrate that, add 1 to the power, divide by the new power. So actually, well, what have we got here? We've got 8 divided by minus 2, which is minus 4, over x squared between 1 and k. And if we sub in those values, that's minus 4 over k squared. Take away minus 4 over 1. I would like to tidy that up. I've got a minus 4 over 1, which is just 4. Take away 4 over k squared. Now that wasn't that hard, and we're not quite there yet because we introduced k. And remember, we introduced k because we didn't feel comfortable dealing with infinity. So let's go back and see what happens with infinity now. We say what happens as k gets bigger and bigger. If k gets closer and closer to infinity, well, 4 over k squared, the bigger k is, the closer 4 divided by k squared gets to 0, doesn't it? If k is very, very big, then k squared is very massively bigger. And 4 divided by something enormous is practically 0. So 4 over k squared approaches 0. So 4 minus 4 over k squared. If you take away something that's very close to 0 from 4, you're left with 4. And so the answer that we were looking for to the integral from 1 to infinity of 8 over x cubed dx is actually equal to 4. There we go. That's quite tough. Hopefully you've done some examples of that. We call this improper integrals, this stuff. There we go. Yeah. Thanks, Harry.
Is it?